Have you ever wondered why some of the JavaScript variables seems to remember their values even after the function in which they were declared in has finished execution? Or why your application slows down over time? The secret lies in closures. Closures is one of the most powerful yet most misunderstood topics of JavaScript. And if you don't handle them carefully, they can lead to memory leaks that in turn can eat your resources. Hey there everyone, my name is Shashank and in this video I'll break down closures in the simplest way possible and understand what memory leaks are in JavaScript. My goal for this video is to help you understand some of the mistakes that can lead up to memory leaks in JavaScript while you are using closures. So let's dive in. What is a closure? Let's say you are at a cafe and you order a coffee. The waiter then moves to the next person to take their order and they do not forget the order that you gave in. Same is the case with closures in JavaScript. Closures are formed when a function with its lexical environment is bound together even after the parent function has finished its execution. Here is an example to demonstrate what closure is. Here in this example, we have initialized a function called outer function. It has a variable called name with the value as Alice. The inner function, which is returned from it, console logs the name. When we call the outer function, we hold its value into a variable and using that variable, we call the inner function. Even though the outer function has finished running, the returned inner function still remembers the name variable and prints it. This is a closure. Now, how do closures work in memory? Normally, when a function finishes executing, JavaScript's garbage collector clears out all the variables that were associated with that function and are no longer needed in the codebase. But with closures, the inner function still holds references of the outer variables or the variables that were declared in the outer function, even though outer function has finished its execution. These variables stay in the memory as long as the inner function exists. Let's take an example. Let's say we create a function called createCounter. Inside that function, we initialize a variable count with an initial value of 0. Inside that function, we return another function which increments the counter variable and logs it. Then we call the createCounter function and hold the inner function into counter1 variable. We're calling this function 3 times. Each time it prints the incremented value. Now counter1 holds the instance of the count variable that was called when the createCounter function was called. Now counter1 variable holds the reference of count variable. Since we have called createCounter function, the counter1 function will always hold the reference of the same count variable as many times as we call it. The dark side of closures, memory leaks. Closures are powerful, believe me, but if you don't use them carefully, then they often can lead to memory leaks. Here is an example. Let's say we create a function called createLeak, and inside that function we deliberately create a huge array and return a function from there which logs the length of the array. If we call that createLeak function and do nothing with the function it returned, then this function will always remain in the memory until the execution of the entire program, and the array will also stay in the memory even though we do not have to use it or we are not using it. This is the issue if you don't handle closures carefully. And if you have multiple such instances in your application, then this will slowly and slowly slow down your application and then maybe crash it. Now we have seen what the issue is, but how can we prevent it? Firstly, use closures, but if you are not using closures, then free up that memory. Let's see with an example. So here we have the same createLeak function and leakyfunc is the variable and we are assigning a value null to it. This is how we are freeing up the memory. Another instance where closures should be handled carefully is by adding event listeners. Let's say we have a button and we have selected that button using query selector and have added an event listener to it. It is our duty to clear the event as soon as we are done with it. By following these simple tricks, you can avoid those memory leak situations and can boost your website's performance. Alright, let's quickly recap whatever we have learned till now. Closures allow functions to remember variables from their parent scope, specifically from the parent function scope. They are powerful but can keep unnecessary data in memory. You can prevent memory leaks by nullifying references and cleaning up listeners. Closures are an essential part of JavaScript, and now you know how to use them smartly and efficiently. If you found this helpful, smash the like button and subscribe to this channel. Also, let me know in the comments what's the trickiest JavaScript concept you have encountered. Maybe I'll cover it in the next one. Thanks for watching and keep showering your love. I'll see you in the next one.